Hi, I'm Professor Goins, and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you're in the right spot, so go ahead and click the subscribe button. That said, get into the current video. I'm going to talk about limit values and function values. Are they the same? Are they different? Are they sometimes the same? Are they always different? What's the story there? So let me start by drawing a couple of pictures. Okay, so let's say that this function on the left here is f of x, and let's say this function over here is g of x. And let's say that the point that I highlighted, let's say this is at x equal to a, and over here, let's say that this corresponds to x is equal to b. And again, I put a closed dot in here just to emphasize that that is actually a point on the graph. Okay. Now, let's start with the one on the right here. If I wanted to compute the y value corresponding to that point, right? So I want to compute this corresponding y value. So what is the y value there? The y value is equal to the function value g evaluated at b. So in other words, to find the y value, you're going to compute a function value. Okay? Now, on the other hand, look at this graph on the left. So corresponding to the point A, there is no point on the graph, right? So there's an open circle there that represents the fact that that is not actually included on the graph. Is it possible to compute the y value there? Well, I can't compute it by plugging in a to the function because we can see that there's no point there. There's no function value. So does that mean all hope is lost? Well, if I want to find the y value for that whole, we actually have a way in the beginning of calculus to do that. So I don't want to write y equals, I'm going to say the y value of the whole is given by the following. We compute the limit as x approaches a of f of x. Okay, so y values of a whole can be found by computing a limit. Y value corresponding to an actual point on the graph is found by computing a function value. Now, also when we talk about limits, we talk about left-hand limits and right-hand limits. So let me take a look at another graph. Okay, so let's say this time my graph looks like this. And let's say this is the function h of x. Okay. Now, I've got two different, and again, let's give this a label. Let's say this corresponds to the x value, say x equal to c. Now, for this function, at the point c, I've actually got two different possible y values that I may be interested in. For one, I've got that one, and I also have that one. So I've got two different y values that are somehow related to the x value c. So let's give these a name. Let's say this is equal to y1, and let's just say that's equal to y2, okay? And how do we compute those y values? Well, to compute y1, Let's think about that. That actually for y1, there actually is a point on the graph there. So really what I could do is we could evaluate f at c. So we could compute the function value because that actually is a point on the graph. Okay. To compute y2, well, again, that's an open circle, so there is no point on the graph there. So what we're going to have to do is we have to do some sort of a limit idea. But notice for this graph that the function values approach different y values if I come from the left of c versus the right of c. So what I want to do is I want to come from the right-hand side of c. I want to be on this graph approaching this open circle. So to compute y2, we have to compute, or we find, the limit of that function as x approaches c from the right. Okay, so we compute what's called a right-hand limit. And that'll give me the y value of that open circle. Now, similarly, if I go back up to y1, you could pretend like, well, what if I didn't have that function value there? What if that was an open circle and the function value either didn't exist or was somewhere else? Well, in that case, or even in this present case, to compute the y value of that point, in this case, we could compute the function value because it is included, or we could evaluate the limit of h of x as x approaches c, but this time from the left. Remember, the superscript of a negative doesn't mean negative number, it means from the left, and the superscript of a positive means through values larger than c, not strictly positive, because I could approach -5 from the right. It doesn't mean I'm approaching through positive numbers. Okay. But anyway, so to compute y values, right, we've got function values, if I actually am looking at a specific point on the graph, but if I'm looking at a whole or a point that's not included, we have to compute either a limit value or a one-sided limit depending on the scenario. Thank you for watching. Please consider subscribing.